1900, the year the word quanta was coined, is where we would pencil in on a historical timeline the birth of quantum mechanics. Anecdotally at least, people are rather surprised when they see the word old being added to their annotation. The timeline is then handed back to them and they are now asked to mark in the date of the new quantum mechanics. Further clarification is offered that explains that this would show when the quantum mechanical wave equation was upgraded to include the newly discovered special relativity of Einstein. 1925 is considered a reasonable answer for the birth of the new quantum mechanics. 1922, 28 was more of a eureka era than a moment. At first, 1922, a beam of silver atoms was magnetically split into two streams. In the world of the old quantum mechanics there was wriggle room for silver with its 47 electrons to account for this behavior. It was predicted that hydrogen with only one electron would not be separated by a magnet. When in 1927 it did separate, it was like exposing one small inconsistency in a defendant's testimony. The case for the old quantum mechanics crumbled. Hydrogen posed a problem as there was no capacity for this effect in the x, y, z dimensions. So, in 1928 the hidden spin dimension was unmasked. In this paper, to give it an equal footing we give it the symbol S. So post 1925 its new quantum mechanics, x, y, z, s. This was a dream for the scientists as they got to work with higher dimension maths, matrices and tensors, see real results and gain breathtaking insights. The lower two elements of Dirac's 1928 electron rank 4 tensor seemed to mean that there was an antimatter version of the electron. This was duly discovered in 1932. At the same time this new quantum mechanics with its extra dimension would prove to be a nightmare for educators who had drawers full of x, y, z 360-degree rotation symmetry objects with surfaces they could tap. The new deal is x, y, z, s, 720 degrees, no surfaces. There is a difference between leaving people with the feeling they know what is going on they get from the old quantum mechanics and the actual understanding gained from the new quantum mechanics and therefore being able to create real world devices. Chemists, engineers building lasers, computer chips and solar cells, or radiologists operating MRI machines, but to name but a few, would partition the timeline. 1900, classical. 1900 to 1925 old quantum mechanics. 1925, new quantum mechanics. The post-1925 science is built on what happens next after this hidden spin dimension was found. It would be appealing for scientists if there was some sort of objective test that allowed all comers to be certain about where these labels were placed so that everyone agreed on the dates. If you could time travel back to a university tea room of 1890, you would not expect anyone to use the idea of quanta or think in terms of tensors. If something is wrong or out of place, metaphorically a dashboard warning light, we pause the line of thought, or driving in the case of the car metaphor, and work out what is going wrong. We should understand that while some people see a warning light and act, the majority just carry on and are puzzled by what is worrying those some people. Within reason you could understand the effort to tie down unexplained results, as with the hydrogen beam splitting of 1927. Imagine you were an MRI radiologist and you had two identical MRI machines, but one was much better than the other at detecting strokes. It is understandable that the scientist of the late 1920s and our MRI radiologist would pause proceedings to first understand what variously is the cause of a hydrogen beam to be split by a magnet, or one MRI machine to give superior results. If you were to stop the average person walking down the street, and you had two envelopes that each contained one of a very clear description of the hydrogen beam splitting problem and the other the MRI machine problem, and you asked the person to pick one, you could then read it to them and then ask them for their thoughts. They would most likely point out that the main issue is that they are now late for their activity. Had they known in advance of this issue, they would have set out 10 minutes earlier. Having played their cameo, our average person walks out of this paper. We have no insight on their capacity to understand. However, we can at this critical stage calibrate our understanding to include the underlying issue of value. If you were to ask the MRI radiographer how their MRI, magnetic resonance imaging, machine worked, they would tell you it does so by getting the hydrogen protons, mostly in H2O, in your body to magnetically resonate, sending out a tiny radio pulse that reports on the health of the surrounding tissue. Wind up the protons, let them persist at different rates, flip them over so the fast persisting ones that were ahead are now behind. The slow coach is ahead, and at a particular moment they will be in sync and your flesh will suddenly emit a radio blip. It is stronger for stroke regions that now appear as telltale white patches on your scan. If you were to ask the MRI radiographer a still deeper question of how the particles worked, they would point to their training manuals that uses solid spheres with surfaces, that is the pre-1925 old quantum physics. Back in the day, 1928, it was realized solid spinning spheres was a nonsense. The supposed surface would have to be moving faster than the speed of light and its spin axis flip orientation still faster. The goal was set to come up with something smarter. The upshot was the new quantum mechanics X, Y, Z, S, 720-degree rotation symmetry, no surfaces. Superficially there is no problem here, as everyone is concerned that at the end of the day what really matters is that the white patches on the brain scan are found. If there is any sort of warning light, it is that the pre-1925 old quantum mechanics is like a movie facade. It is not real. Now if you are coming at this from the point of view that science as entertainment, or meets some sort of time or cost constraints so that something reaches the most people, then the as a facade the pre-1925 old quantum mechanics has cornered the market. The issue is consent. What is the difference between cultivating a dependency on a line of thought without people's consent and brainwashing them? Do you have an obligation as an educator to make clear that the spin of the new quantum mechanics is not the spin of a wheel, coin or bottle? How much of the new quantum mechanics can you omit and the old push forward before you would be cultivating? Are there any power imbalances in society that would mean at least some parties would think consent was a good idea? It would be taking a rather philosophical approach to muse that John Locke had uncovered a hidden dimension of political life when he articulated the need for consent of society to be governed. Some historians have likened his insights as lighting a fuse that led to the American and French Revolution. In this case we are primarily looking at education liking what they can teach, and science liking what works. So, inasmuch as neither education nor science is political, any issue of consent would only be a concern of the uneducated masses. Anecdotally at least, people are rather disturbed that having marked dates for the birth of the old and the new quantum physics, 1900 and 1925, to be then passed the timeline for a third time. What major event is there to mark? When, or rather when will, as it has yet to happen, there be alignment, when what is taught actually works, and we put the cans of old quantum physics with the best before 1925 date back in the museum? The good citizens of anecdote make good progress at first placing their pencil to the right of now. as it hasn't happened yet that would place it in the future. But how far in the future? Normally you have to allow time for the things that have to happen first to get done. To estimate the time to do things, our anecdotions will need a succinct snapshot of the end product. What is needed is the equivalent of a residential development showroom for instruction of the new quantum mechanics. You want to see the architect's impressions with the all-important Haber views through the windows. The details of the underground car parking and trenches for the services are important but not relevant at the initial interest stage. With this in mind, a lesson plan is now introduced to aid visualization much as the architect's impressions communicate to a prospective buyer. The following is a lesson script read and presented by a teacher. Year 8 New Quantum Physics, Sample Lesson Plan. Teacher's script. Who has an allergy to maths? Who would like to hear the reduced maths version of New Quantum Mechanics? Let's start with a 10-letter sign. FM well sign. What does FM well sign bring to mind? Perhaps a thumbs up on the outside of the local radio station, showing they are doing well in the ratings. Each letter is code for a key idea in quantum physics. Here is the code sheet. 1F Aussie no balls. 2M Agic bag. 3W Avi Mikwa phase. 4 electron absorbent. 5 Elite rocks space. 6 Elite chaser rotation. 7S exis. 8 IS. 9G host Saudines. 10N ested tables. You are about to hear a passage that gives some information about the 10 letters of this sign. After hearing this, you will be asked to break into groups of 4, told what the challenge is, read the passage again for a second time and given the rest of the lesson to complete the challenge. In 1934, someone suggested that the center of the atoms was a clump of ball-shaped protons and neutrons. Schools liked this picture, but scientists looked and found no balls, only a fuzz. The scientists found that particles were not like Santa's sack that gets bigger when there are more presents stuffed inside. Electrons, protons and neutrons were smaller with more mass, stuff, in them. Electrons are way bigger than protons. Light is like a song note coming out of a songbook. The electrons pulsate in space to a new shape. Matter sponges up electrons. The average nucleus of say 7 plus charged protons can hold onto 8 charged electrons. Light emits from an atom, rocking the atom back and space forward. Electrons are too small to put a mark on them. You can't see them rotate or spin, and this actually means they don't. They have something called a complex phase, and when this is shown as a color, it looks like a color chaser light going around. When they mixed E equals mc2 into the old quantum mechanics, out came the new quantum mechanics with a new dimension S. Called spin, but the particles don't actually move or physically spin. Fundamental particles, electrons and quarks, have no smaller parts, so there is nothing inside them making them have properties. They have no surfaces. They have the feel of a flywheel, but nothing is moving. Protons and neutrons have 3 quarks and 99x more mass from virtual matter antimatter pairs. Electrons merge through each other like ghosts. They pack into atoms as in the hiding game Saudines. The periodic table has 4 blocks of subtables like nested tables. The property pattern is repeated on each of them. You will split into teams of 4 after these instructions are read. You will select one team member to collect 10 blank cards and 4 pens. You may not use mobile phones to photograph or record. The FM well sign point headings will be displayed, no writing. You may discuss strategy in your team. The FM well sign point heading will then be read out, no writing. The passage you heard before will be read out, no writing. Your teams have to fill out the cards. O advice that the best results have been from teams that have more than one person covering each point. O for the test game after it is best to have the letter on one side of the card. At completion teams will score each other. This concludes the instructions. Are there any questions? These instructions will now be read step by step, but now follow each step. It may take several reviews of the lesson plan to drill down through the various layers. At first it is evident that it is written for a class of high school students who are around 14 years old. Then you would need to have produced a sign, have the code sheet displayed, have the script and appropriate cards, about 100, for the activity. Then, if you were a teacher, it would be wise to be clear in your mind how this may be different from what you may have been most likely learned while you were at school. Principally, atoms are not mostly empty space, nor does a dot electron skip from one orbital to another, the so-called quantum jump, generating light. It is no secret that according to the current textbooks and syllabus that it is planned to carry forward to the new generation the old quantum physics that was imprinted earlier. This has the atom mostly empty space and as if by magic quantum jumps. At a certain depth of drilling down into this lesson plan the deal comes into focus. Although there may be legitimate doubts as to its education efficacy, based on years of hands-on experience, it is plausible that it could be made plausible. This then, would mean the meta issue arises, the implications of breaking ranks. Everyone is teaching the old quantum mechanics, albeit to an audience that is immersed in the benefits of the new. Breaking ranks is the big ask, it is the deal. The strategy adopted here is to successively offer less and less challenging substitute questions. Would you break ranks? Is substituted with could you mark on a timeline when you believe that there is going to be alignment? This is further substituted with could you mark a historic date on the timeline? The reader will note that in this paper that the substitution order has been reversed. When a level that is reached that causes difficulty, one can dial back to the previous level and build forward from the last known working visualization. There is also substitution of content to find a level optimized for engagement. The following 3 paragraphs discuss SU 6, SU 3, and SU 2. All are at the heart of the new quantum mechanics, but with no lead-in sit at a too complex level for the novice. The new quantum mechanics is not intuitive, given our intuition comes from experience of our Euclidean world. The up-to-date version uses the standard model that has non-Euclidean SU 6 symmetry. This can be simplified in that SU 6 equals U1 XSU 2 XSU 3. SU 3 is at the heart of quantum chromodynamics, QCD, that accounts for the behavior of quarks. Our understanding of color is cleverly reproposed as a conceptual scaffold. Similarly, SU 2 is in new quantum mechanics of electrons and protons. Here our understanding of spinning objects is reproposed as a conceptual scaffold. What is required is selecting some but not all of our understanding and adding new ideas. We want to get the idea of a flywheel or stabilizing gyro. We want to get the idea of a magnet. We don't want to get the idea of anything actually moving. We don't want to get idea of axis poles that can be pulled around so that north now points south, but probably closer to a sock that gets pulled inside out. Here we have substituted this complexity for an equivalent of the architect's impression or the lesson plan. As with the architect's impression displayed in the site office, the idea here is to kickstart the plausibility discussion. The teacher no doubt would like to see this lesson presented at education conferences and trialed. evaluated and iterated in real classrooms. The scientist no doubt would like to see these insights build a robust understanding of solar cells and nuclear reactors. It is the strategist for which an endpoint, albeit yet to be set in stone, suggests many start points and strategic scenarios. Simply put, alignment? How is that going to happen? Let's look at the possibilities. What are the possible time frames for alignment? Now, in the future, or never? If you were to take a step back and observe that in a society you are going to encounter all three views, you would be in the company of strategists. Each group will have needs, and planning for how their behavior and how they interact will shape any plans. What is the strategic change of guard transitioning to alignment? In 1928 a problem was solved. We now could understand why a magnet split a hydrogen beam. With this jigsaw puzzle piece, we could see into silicon, imagine, then build the computers which are loyal sevens. We could see into our own brains. The only problem was the solution didn't drop out with a second education solution. What we have seen is a substitution of a simpler problem for a more complex one, the old for the new. We have seen in this paper that if done strategically, substitution of simple for complex can be engineered as a ladder of understanding. What education has done is drag out a step ladder and congratulate people on reaching the top. When the students look over to the longer ladder and scientists on the roof, the response is to shout next. The new guard involves those who can understand and articulate the objective of the new quantum mechanics. Further, they can understand and articulate the strategy to get to the objective. Surely it is when the average person walking down the street believes the objective has value, the strategic dynamics will change. Education has been talking over science. It has also gone off course when the new replaced the old quantum mechanics and there was a need for a change of course. Perhaps it's time to use a map rather than clench the steering wheel ever harder.